And welcome everybody to the Daily Space Weather. What we're looking at here is the northwestern limb of the closest star. There's a filament up there. It's about 3 Earth diameters in length, and sometimes filaments erupt. More on that later, especially since there's a coronal mass ejection headed Earth's way once again. We'll get to it. First, here's the same area in a different wavelength. So the first one we showed you, this is 193 angstroms, one of the ionized spectral states of iron. The UV emissions thereof from the Solar Dynamics Observatory, here's 171 angstroms, a different ionized state of iron and its ultraviolet emission spectra. We've got a new sunspot has formed down here also, this area right here. That is a new sunspot. We'll see if it hangs around long enough to get a name. Let's talk about the coronal mass ejections. Now, yesterday's Daily Space Weather video, you may have noticed, included the words coronal mass ejection warning. And that is because one was unfolding as we made yesterday's video. So let's head out to stereo A at Lagrangian point 5, which is located right here under my pointer, to see what the view is from out there. So yesterday, we cited the fact that there was going to be a coronal mass ejection in the Earth-facing vicinity, and indeed there was. And the methodology that we use to forecast coronal mass ejections will not be disclosed, at least not yet. There are many criteria that need to be met before we can explain how it is that we forecast coronal mass ejections before they leave the solar corona. But in any case, we've been doing it. So you can see this bubble coming out of the Earth-facing side. And again, just to go back to the diagram here, Lagrange point 5 is located out here, which would put Earth off to your right from the perspective of the stereo A spacecraft. So we saw coronal mass ejection on the far side of the Sun first. That began to release around 1900 on May 13th. And then right around midnight, we saw this additional coronal mass ejection in the Earth-facing vicinity. Part of the ejecta is headed in Earth's direction. It's very diffuse. It's not a lot of ejecta. And we're going to show you a different perspective here as well. We do expect some geomagnetic effects from this Earth-facing coronal mass ejection. Some of the ejecta we are expecting to make it to Earth's geospace. So just to give you another view here, let's go to Lagrangian point 1 and take a look at the Soho-Lascaux C3. I would also note the date stamps here. They are different. This is a different run. We're mainly only focusing on the Earth-facing coronal mass ejection. And you can see a lot of the ejecta actually headed up to the north. And it may be difficult to see here. The contrast is not great on this imagery. I'll just let this play through here. You can see most of the ejecta did go out to the north, up in this direction. Some of the ejecta is Earth-facing again. And there is also a coronal mass ejection on the far side of the Sun propagating, which can make it very deceptive looking. And just to give you another view of that from stereo A, you can see there was a coronal mass ejection on the far side. But what we're mainly looking at there is a pretty diffuse coronal mass ejection. Some of the ejecta actually remained in the corona. There is a possibility for additional coronal mass ejections today. We'll keep you posted on that as well, probably making another video later if we see additional material ejected from the solar corona. And next we've got a full disk view of El Sol back to 171 angstroms. Again, we've got a new sunspot. It's likely to be named Sunspot 2824 if it is indeed in place long enough. Here's a colorized magnetogram, and you can see this sunspot forming right here by my pointer, right there. And it's pretty small. And the radial flux is actually down to 71. First, a diagram of the solar system. Here's where stuff is. And we've advanced that 1 week to show you 1 week in the future. Here's a star chart. We show it daily. I use in-the-sky.org. I face mine to the south, and I draw in the ecliptic, which is this yellow line, the sun that the path will take across the sky. The path that the sun will take across the sky. The 10.7 centimeter radial flux, the radio output of the upper chromosphere, which is this very little edge here, and the lower corona, the lower portion of the sun's atmosphere, only 71 solar flux units. Here's a 1-year chart to put that in context. The black line is the radial flux, the red line is the sunspot number, and the blue line is the Potsdam AP index, the interplanetary magnetic field measurement, which has dropped right back down following a brief spike, as you can see here, showing up at the same time as the coronal mass ejection and intensifying the geomagnetic effects thereof. We are expecting a coronal hole wind stream to arrive late in the day on the 17th. So late in the day on Monday, expecting a coronal hole high-speed wind to show up. And on the 18th, we're expecting some ejecta from the coronal mass ejection. I would forecast a KP5 or 6. I would not expect it to be a KP7, as it is not as dense or directly Earth-directed as the previous coronal mass ejection, which caused a KP7 geomagnetic storm. Next, seismicity. We are seeing indeed an earthquake lull. You can see it's been a couple of months here since we've seen a 7 magnitude quake here on planet Earth. And earthquake lulls typically end in earthquakes. VolcanoDiscovery.com's got great data on that. So here's the 3+ magnitude quakes in the past 24. Here's the 4+ magnitude quakes. And here's the 5+ magnitude quakes. It looks like 5 of those have occurred in the past 24 hours, mostly in the southern Pacific. Let's go up the list here on the USGS site. I'm just going to let it scroll here. There was a 4.5 magnitude quake at over 100 kilometers depth at India. There's a location of that one. East India, actually. And I'm just going to let the list scroll here. Not very many significant quakes of note. Although there was a second deep quake here at Indonesia. That one of 4.5 at 198 kilometers depth. Also one near Easter Island at a 5.4 magnitude, a 5.5 at New Caledonia. Again, folks, if you're in an earthquake-prone zone, I haven't said it recently, if you're in an earthquake-prone zone, be prepared for earthquakes. Again, the 7 magnitude earthquake lull continues. And leave us a comment if you felt this 4.1 magnitude quake in Italy, or if you've been tuning into the Giro d'Italia. Let's check volcanoes over the past 24 hours. And we've got another new one added to the list. We'll get to it. First, Abico. Report on that is a flight level 080. It's an 8,000-foot ash plume. Subanosejima also continues to erupt. 6,000-foot ash plume over it. And Langila on New Britain, one of the Papua New Guinea archipelago islands, has been exploding and producing a 10,000-foot plume of volcanic ash. Dacono exploding as well, 7,000-foot ash plume there. Pacaya in Guatemala, as well as Fuego in that country. Pacaya volcanic ash has dissipated from it. And Fuego still exploding, 15,000-foot ash plume there. Sabancaya in Peru exploding, 24,000-foot ash plume there. Nevados de Chilean were unable to detect whether or not it's erupting. Don't take it as an opportunity to pole vault the caldera. We don't want you to have unfortunate health results. So please don't pole vault the caldera. This public service message brought to you by smAsho.com. And let's get back to some space data. Welcome to space. The GOES X-ray flux not showing any significant solar flares, as degradation has been occurring in the sunspot groups. And a reduction of the radial flux. Proton flux not showing any spikes. There's the flat 3-day chart on the GOES proton flux. And once again, we're not expecting any spikes on this from the incoming coronal mass ejection, expected to arrive on May 18th. GOES magnetometers showing some spikes here. And again, there is a coronal hole wind stream on the way as well. We can expect some sawtooth patterns when that arrives, especially. And we're seeing a more normal range here, although some, again, pretty spiky sawtooth patterns here in the past few hours from the GOES magnetometer. An indication of plasma in between Sun and Earth. Next, looking at the top view ecliptic plane field plot, part of the National Sunspot Observatory. It's based on 51 ground-based magnetometers and magnetometers out at stereo A and at stereo B. It's showing us the polarity of the current sheet by using radiography and magnetometers. And Earth is solidly in a South Pole current sheet, not expecting a change in that anytime soon. South Pole current sheet shown here in red, North Pole current sheet shown in green. Here's another view of the same data. Line of sight ecliptic plane field plot. Pretty uneventful there. And the line of sight coronal hole plot showing some significant coronal holes, especially in the southeast. Also, it's showing you the sun's B field in blue as this magnetic section of the video continues. Here are the coronal holes and the sunspot groups. So on the Integrated Space Weather Analysis Center, this is right on the first page here. Sunspot groups and detected coronal holes. And you can see this new sunspot forming here, just getting an alpha designation there. Sunspot 2822 is also alpha. We've only got alpha class sunspots. The likelihood of significant solar flares has dropped, but I would remind our viewers again that the possibility of additional coronal mass ejections remains. The KP index, a measurement of global geomagnetism, currently at 3. And there's a 3-day chart of that. A KP of 3. Geomagnetic calm conditions. Next, the real-time solar wind. Pretty uneventful here. We are seeing a climbing of the solar wind speed over the past about 12 hours. Current solar wind speed 464 kilometers per second. Current solar wind density 6.14 protons per cubic centimeter. Next, our Geospace Magnetosphere movie. It's 4 hours of data courtesy University of Michigan of the magnetohydrodynamic pressure shown in nanopascals. And we may see a small uptick here in the pressure as we've seen the solar wind speed rising over the past 12 hours. Although pretty steady as she goes there for the geospace. Next, ground magnetic perturbations. And we do see significant ground magnetic perturbations here around both polar regions, as well as some crossing the Indian Ocean here. So since there's a polar excursion going on, a geomagnetic excursion, folks, we show this daily as well. It's 4 hours of data, just like the last Geospace Magnetosphere movie. We've got 2 north poles, and we're showing you the perturbations associated with the polar excursion. Now, we do regularly stream live to Twitch. And welcome to our Twitch viewers. We've decided to go live for today's cosmology segment. It'll be integrated into the daily space weather video, unlike yesterday's cosmology segment. If you missed yesterday's daily space weather video or cosmology segment, check them out. They are separate. Today's is not separate, it's integrated. So let's get to it. Twitch.tv/smAsho. We're also on BitChute. Check out our exclusive content there. Thanks to our new subscribers over on YouTube. Don't forget to press like and subscribe. Share with your friends, foes, science noobs, and science pros. Tell them about the channel. Welcome them to the Neo-Renaissance. Visit our own site. Today's featured product is available at this link right here, smAsho merch. Thanks to everybody who's been picking up merch. It really helps us out a lot and helps to support our cause. Today's featured merch is the Vaccinate This classic t-shirt. Since my vaccination status is none of your business and HIPAA has not expired with the pandemic, perhaps pick up one of those. I like the blaze orange color because nothing says don't run me over or shoot me like a blaze orange shirt. Today's cosmology segment's got some interesting features. How about solar wind coming from the center of the Earth? How could that be a thing? It's got to do with isotopic ratios. Isotopic ratios, that's right. Is it possible that the Earth's core sucked up solar wind material billions of years ago? Well, it's entirely possible. But in any case, mantle plumes showing a very consistent isotopic ratio between helium and neon, consistent with the solar wind, an indication that there's a little bit of the sun inside the core of the Earth, perhaps. So maybe check out this article on phys.org, and I'll just let it scroll in case you'd like to read it right through our video. Today's random number is 367, which coincides with a quite interesting object. A tidal disruption flare. Yes, so a tidal disruption flare, folks, is what happens when a star gets eaten by a black hole. Does it really get eaten by a black hole? That's the real question. And ultimately, the answer is that we don't know. So this object here, the Swift J1112.2-8238, is a tidal disruption flare. And this is possibly a star being sucked up by a black hole, a quote, black hole, end quote. A massive flare that came out of a now dark part of space. So I would show you this on the Sinbad or the Aladdin light. It's just that there's nothing to see. Although this apparently star, which is now gone, is still producing X-rays. So here you can see the daily chart of this, quote, tidal disruption flare, end quote. And this X-ray source has been producing X-rays over the past 16 years, despite being a, quote, tidal disruption event. So whatever was going on with the massive radio source here, we ultimately don't know, but it's still producing X-rays, which are coming out of a dark part of space. Let's move on. And by the way, again, today's featured object is number 367 at the Neil Gorell Swift-Bat X-ray Observatory. It's got 1,031 objects that are monitored in terms of their hard X-ray output. And that's what we came up with today, number 367, a tidal disruption flare X-ray source, Swift J1112.2-8238. Let's talk about a totally psychedelic stellar nursery, bruh. It's crazy, bruh. And here it is, located about 5,000 light years away in the constellation of Sagittarius. This lagoon nebula here is quite a spot, and what you're looking at here is a composite of infrared light and by the way, that's in false color since your eyes can't see infrared light and visible bands from the 8-meter Gemini South telescope. So this is about a 20 light-year section of space, again located at about 5,000 light-years distance in between the Sun and the galactic core in the Sagittarius constellation. The southern cliff in the lagoon. A bunch of dusty areas, and there are some Herbig-Haro objects there, which are a type of very dusty oblong stars. We won't get into it in today's cosmology segment. Next, I'd like to thank our patrons, the true stars and sources of funding for our content. Please consider becoming a patron if you'd like even earlier alerts than you'll ever receive on places like YouTube, Twitch, or BitChute. Patreon.com/smAsho. Also, you get all kinds of cutting-edge science information, the latest of what we're up to, behind-the-scenes stuff, multimedia, music, ringtones, and more. Let's talk about a supernova. What's going on with this supernova? Well, it's interesting to say the least. How did it do what it did? It's completely outside the realm of normality when it comes to supernovae, which aren't particularly normal in the first place. Why did this star have practically no hydrogen on its surface when it went supernova? This is not believed to be a thing that's possible. So, how did it happen? Could it be because the standard model of stellar evolution is completely wrong? That would be my first guess. Could it be because stars are made out of condensed matter and not diffuse gaseous plasmas? That would be also consistent with my first guess. And we're just letting the article scroll here. This is from SciTechDaily.com. Why are the chemical abundances as they are? This star's discovery, here's a quote from the article from Charles Kirkpatrick, astrophysicist. This star's discovery provides some of the most direct evidence ever found that stars experience catastrophic eruptions, which cause them to lose mass before an explosion. Now, the supernoval output from this star did collide with a cloud of hydrogen. Did that come from the star originally? Well, the answer is we don't know. But there is a possibility that for some reason, stars shed their hydrogen before exploding. What do they do after that? What do they do before that? Who the heck knows? But that's what's going on with that, and you can find the full article linked on the SciTech Daily article. The full paper, a cool and inflated progenitor candidate for Type 1b supernova, 2019 YVR at 2.6 years before explosion. The full article, again linked at SciTech Daily from their article. Cheers! That's today's cosmology segment. And we'll say goodbye to Twitch. We'll bring you back, Twitch, for the meteorology segment. Next, we're going to talk about electrons. Electrons surrounding planet Earth. We're not going to talk about where they come from, as that would be for a cosmology segment as well. Here are diagrams of the Van Allen belts and distances in miles. The Earth usually has 2 of them, and during geomagnetic storms, it gets a third. Here's the relativistic electron flux over the past year. You can find this graph yourself at solon.info/solar. Here's a 3-day chart of the electron flux, and we are expecting a precipitous uptick coming soon. Perhaps today we'll see warning levels for electron flux. We are already seeing some charging hazards here over places like Mexico. So electrons out there in the geospace around planet Earth can charge up satellites, and that's what we're showing you here, some charging hazards. And you can see Noah and I both agree here on the coming increase in the electron flux just ahead of the coronal hole wind stream, which is just ahead of the coronal mass ejection strike. Here's a total electron content forecast. This is a visualization of the whole air column, and the electron regions here are looking a little bit more, well, they were looking a little more organized, and at that point they're looking quite chaotic. So pretty chaotic electron belts here at nighttime over the Atlantic Ocean and over West Africa. You can see there quite a lot of electrons here despite it being at nighttime at that point in the total electron content forecast. This shows you the electron density all the way from your handset to a GPS satellite. Next, the ionosphere layer, which is located about here, 300 kilometers of altitude. And we're actually showing you 2 days here of the ionosphere. We're just going to let that play through here. Keep in mind, folks, it is approaching winter time in the southern hemisphere, aka the solstice. Northern hemisphere summer. And this does indeed affect the ionosphere, as the angle of the incoming solar radiation and particles and magnetism and so on are affected by the location of things, such as the Earth's axis on its orbit. In any case, here's the latest image coming in at 10 o'clock Universal Time. Things looking fairly normal at that point. Again, the F layer is located at about 300 kilometers of altitude. This is the D layer and the E layer, and the F layer is the layer above the E layer. And this diagram also shows you penetration of electromagnetic radiation through the atmosphere, temperatures, and chemical densities at different portions of altitude. Next, we've got a meteorology segment. And let's welcome Twitch back for meteorology. Welcome back, Twitch, for our meteorology segment. We're going to start out looking at surface winds of the Western world. So here are Earth's surface winds in the west. Let's look at the jet streams. Here are the jet streams of the Western world. A little bit more coherent in both hemispheres right now, although doubled up over the North Atlantic Ocean. Here are the jet streams of the eastern world. We'll rotate it just far enough to see New Zealand. A little less coherent in the northern hemisphere portion of the east. strong jet streams in the southern hemisphere. Here are the surface winds and a very strong cyclonic system here in the North Pacific, south of the Aleutian Islands. And also one off the coast of India there. That one's looking pretty strong as well. We'll leave it there and look at some more local stuff. But first, lightningmaps.org. And we're seeing lots of lightning here in northeastern Europe. Shout out to Eugene Bagashoff. Drop me a line. Have you heard thunder? When I hear thunder, I go to lightningmaps.org and I try to convince the natives that I'm Thor and that I'm causing the thunder. Or perhaps my dad sent me a text message. You know, my dad, Odin, sent me a text message and informed me that I should create some thunder to go along with his lightning. Lots of lightning here in northeastern Europe. And we see some terrestrial lightning in the U.S. just kicking up as we make the video north of Tulsa. Hey, if you're in Tulsa, go out and look to your north. Take some time-lapse photography above the cloud tops. You may see some red jellyfish, green elves, sprites, or who knows what else. Maybe you'll see gremlins up there. And here's the NASA GOES lightning mapper. Quite a bit of lightning here across Kansas, moving into Oklahoma, Missouri, Arkansas, etc. Also some in West Texas. And Iowa, actually. Quite a bit of lightning across Iowa. Here are pressure cells right now. We're going to advance this into tomorrow. Here's where we expect pressure cells to be at 1 p.m. Eastern Time, Eastern Daylight Time tomorrow, according to the Euro forecast, the European model forecast. Next, a U.S. Doppler radar map. Here we've got some heavy precipitation here over Kansas, just about to move into Missouri, northern Arkansas, and so on. It's moving a bit to the southeast. It's moving east-southeast at this point. Here's what's going on in the cloud layer. And the water vapor map should give you the best insight into the movement of these systems here. And there's not a lot of impulse from the west there, so these will be fairly predictable but fairly slow-moving systems. So while they're not colliding with dry air ahead of them, they're not being pushed by massive air behind them either. And when you're looking at the Doppler, if the Doppler isn't giving you enough information, the water vapor should really help you out, as water vapor cannot hide from the NASA GOES Interactive Weather Satellite Water Vapor Map. And that's today's meteorology segment. See you later, Twitch. We'll see you next time as we continue with the daily space weather. Here come bonus features in the form of the latest hydrogen alpha imagery from the Tiday, Spain ground-based solar observatory. So we've got an animation of that here. Again, possibility of additional coronal mass ejections remains. Likelihood of major solar flares has dropped a bit. Here are the solar intensity gram and magnetogram. So here's the latest intensity gram. Possible sunspot 2844 right here. Sunspot, not 2844, 2824. Here's 2822, which looks like it's continuing to degrade here. 2823, also continuing to degrade, but possibly a new sunspot there, 2824, and it could be a beta class. Let's take a look at the magnetogram here, and that is indeed already a beta class sunspot, folks. So there you can see the fields. You can see there's a North Pole field right here and a South Pole field right here, two separate umbrae. Likely to get a name today, sunspot 2824. I'm calling it. And we'll close things out with a couple additional views of the sun here. Here's a full disk 193 angstroms view from the SDO. Great view of all three active regions here and coronal hole right here. I'll let that play through on one more run. And we'll close things out at 304 angstroms on the full disk view. Again, likelihood of additional coronal mass ejections is still there, folks. Although I'm not calling it a warning today. In any case, thanks for tuning in. Remember to stare at the sun. Perhaps use our channel. And congratulations in finding our channel, by the way. And may that solar wind be at your back.